Hello and welcome to HiveScience. We got some strange science on the menu for you today, so I hope you guys are ready. Thank you so much for popping in to watch a little bit of HiveSci. The topic on the agenda for today is tickled rats reveal brain structures that control laughter. Rodents' squeaks may shed light on neural mechanisms of play in humans. Yeah, and they're going to tickle these rats. Do rats like to be tickled? The furry rodents can be quite fun-loving, scientists say. And yes, under the right circumstances, they do enjoy a bit of rough and tumble play, letting out high-pitched squeaks akin to human laughter. Now, researchers say they have identified the area of the brain responsible for this playfulness. The discovery reported today in Neuron represents a fantastic step forward for understanding the neural basis of play and laughter, says Sergio Pellis, a neuroscientist at the University of Lethbridge, who was not involved in the study. Of all mammalian behavior, play is one of the least understood, says Michael Brecht, a neuroscientist at the Humboldt University of Berlin. Neuroscience tends to focus very much on aversive things, he explains, such as the brain region behind aggression and fear. Play remains a mystery. There's relatively little research on positive emotions, Brecht says, which I tend to think is a mistake. The research that does exist shows rats will keep playing even after their entire cortex, the part of the brain essential for consciousness and high-level behavior, has been destroyed. This suggests that play, like fear, is instinctual. Some studies propose that a structure called the periaqueductal gray, the PAG, which plays a role in vocalization, the fight or flight response, and other behaviors, might be involved. When rats play fight with one another, they exhibit behaviors that mimic fear and aggression. So Brecht suspects that the PAG or a similar region of the brain might be responsible. Rats are capable of particularly complex forms of play, similar to those seen in humans, Pellis says. In one previous experiment, Brecht's team even taught the rodents to play hide and seek. At the beginning of the game, the rat was enclosed in a box while the researchers hid somewhere in the room. The researcher that opened the box used a remote control, allowing the animal to jump out and begin seeking. When the rat successfully found the hidden scientist, it was rewarded with, you guessed it, a tickle. The rats were also given the opportunity to hide while the researchers looked for them, and they proved to be especially good at coming up with creative hiding spots. This ability to strategize was almost spooky, Brecht recalls. To further investigate the PAG's role in play, members of Brecht's team first made sure the rats were comfortable with their new playground, aka a dimly lit plastic box, as well as their human playmates. The researchers then played games of chase the hand and tickle and the animals on their backs and belly. See the video below, which we will be looking at for examples from the behavioral experiment. In response to the tickling, the rats shimmied in delight and let out endless giggles. During the play session, the team monitors the rat's brain activity with brain electrodes. The small implanted wires allow the animal to move around freely, while a suspended ultrasonic microphone monitored their laughter, which is too high-pitched for humans to hear. When the rat was squeaking and engaging in play, a distinct region of the their PAG lit up with activity. When the rodents were instead placed on a high platform under a strong light, conditions that make rats anxious, they stopped squeaking and their PAG neurons went dark. This implicated the PAG on the rat's playful behavior, but it wasn't entirely responsible for it. When the researchers injected a chemical into the PAG to stop neurons from functioning, the animals stopped squeaking when tickled and lost interest in their human playmates. This result suggests the PAG plays a crucial role in ticklishness and play, the team concluded. In the future, Brecht hopes to investigate whether the PAG also contributes to other aspects of play, such as following rules. It turns out that rats are big sticklers for them. In the hide-and-seek experiments, the rodents quickly lost interest when the humans used the same hiding spot over and over or failed to properly conceal themselves, he says. Play is vitally important to the well-being of both humans and animals, says Jeffrey Bergdorf, a neuroscientist at Northwestern University who was not involved in the study. Past experiments have shown that when certain animals are deprived of play, they become depressed, fail to form relationships, and are less resilient to stressful situations. Lack of play has even been shown to stunt brain development. Bergdorf thinks Brecht's cutting-edge work in rats could help uncover the neural mechanism of play in humans. By understanding how the brain processes positive as well as negative emotions, he says, researchers may be able to develop more personalized and effective treatments for patients who suffer from anxiety and depression. Brecht, for his part, hopes that his work will lead to a greater appreciation of play among the scientific community. As this new study demonstrates, the desire to play may be hardwired into our brains. If we don't get enough of it, the consequences could be severe. A bit more tickling probably couldn't hurt either. All right, we're going to watch the video now. It's only 16 seconds, so make sure the volume's good and you all should be able to hear. We're going to blow her on up. Here we go. Sure didn't stay on the screen very well. But yeah, I could hear it. So that's the rat tickle. All right. So that was our strange science for today. Thank you for sticking with me and checking out these rat tickling experiments. It's a little bizarre, but that's what we do here in Strange Science. Please remember to be kind, take care, and we'll see you next time.